Welcome back. In this video, we're going to review and get familiar with the concept of database normalization. Let's say that your friend has started up a wine and cheese shop where they sell to various customers around the country, and they asked one of their employees to put together a spreadsheet to track sales. And this is what their employee came up with. So let's see what we have. You can see we have an order number, the date of the order, and then some information about the customer, including a customer number, last name, first name, state, zip code, the amount of the order, the tax rate to be applied to that order, and then the various products in the order. So we've got product one, how many, the quantity, the description of the product, and then we have the same thing for product two and product three. Let's take a look, and right away it looks like we may have some data quality issues. So let's see if we can figure out what some of them are. All right, so it looks like we've got inconsistent product descriptions for one of our products, wine spritzer, wine cooler. Which is it? What's more, so let me see if I can highlight these. What's more, look at that. They just completely messed up. Looked like instead of the 4, they may have let their finger slip down and type R a few times. 4RR. What is that? All right, what else do we have? And these are some things that you may want to consider when you're dealing with data. So let's look at some of the questions that we may ask. All right, so let's say customer 1135 decides to change his name, goes through the legal process, notifies you. Instead of John Black, we've got Captain America now. All right, so there's 1135, John Black. Here's another John Black. Oop. And here he is again, but this time he's coded as 1136. All right, so look there. We're going to have, if we do things right, we'll find those 1135s and change those all to Captain America, but we'll still have 1136 left with John Black. So there's some inconsistent coding going on there, and that's the same thing we saw with the product number, 4RR. What if Don Smith cancels his order? All right, so here we have an order to Don Smith. Turns out it's the only order he makes. All right, so he calls to cancel his order. We're going to delete this order record. All right, so now the order's gone. What happens, say, a month later when Don Smith calls us back up and says, hey, I'm ready to make an order? And we go, well, great. Who are you? Don Smith. I should be on your customer list. Don Smith. Oh, no, we don't have any Don Smith. So here it just makes the business look bad. They're not keeping track of customers. All right. How do we add a new product? Product 475, which is a hard seltzer. Well, I guess I could go down here and say 475 hard seltzer. All right, but am I allowed to do that? Or do I need some kind of an order? How can I tell my customers I have hard seltzers if this is my database? If it's not in the database, how can I add it to the database without an order that a customer has made? So that's an issue. And we saw that, this clerk here entered wine cooler a couple times instead of wine spritzer. So we've got a lot of data errors, data inconsistencies in this unnormalized data set. So what can we do? Well, when it comes to databases, we generally, for companies' ERPs or accounting systems, we aim for something called third normal form. So there's a process you can go through called database normalization, or data normalization, it's often called as well. So we go through the steps one by one and say, well, how can we bring this to the next level of normal form? So if we have an unknown data set, and in this case, unnormalized, the first thing we look for, are there any fields in this data set that repeat the same type of information over and over and over again? So 2 hints there. If you've got field names that are basically the same and repeat over and over again, that's one clue. The other clue is you've got a ragged set of records where some records are longer than the others. So you can see here we've got 2 products in order. Here we have three products in order. Most of our orders just have the 1 product. So, and we look at the descriptions. We're repeating, product description, quantity. Product description and quantity again, product description and quantity. So really, we're talking about products in the order, and we should pull those out into a separate table. All right. So that's what we're going to do. We're going to identify repeating fields and create a new table from those. So I move over here to first normal form. All right. And what I've created is my order detail table, and in that I've got my order number and all of the customer information, zip code, the amount of the order, the tax rate, just like I had before, but I've pulled all the order number, or I've pulled all the product information out into a separate table, and I'm going to call this the order detail table. So basically these are the details of each order. So you can see now, instead of having 3 lines here for order number 253, we have 3 lines in our order detail table. Now, because we have to relate these tables back to each other, we end up duplicating that order number in the order detail table. All right. And let's take a look back here in our unnormalized data. If we look back here, we see that we just have 1 table, and it's just got a bunch of fields in it. All right. Now, let's go back to first normal form, and you can see here we've got 2 tables now. We've got an order table and an order details table, and we have a line between them that indicates, hey, these tables are related. And we're going to get into that as we move ahead with this reading module and get into UML class diagrams, but those numbers or multiplicities at the end of that association line give you some information about that association between those tables. All right. So we know we've got an order table. We've got an order detail table. We are now in first normal form. So now we're going to look to see if we can figure out how to move to second normal form. So the rule to move to second normal form goes like this. For any field in a table that is not dependent on the full primary key, move it to another table. All right. So the words full primary key kind of indicate that we're going to use what we call a compound key here. And that is a primary key that's made up of more than 1 attribute. So here we can see that eliminates order. The way these boxes are laid out in this diagram, the asterisk indicates that that is the primary key. So order just has order number as the primary key. Order details, you need both the order number and the product combined to identify a single record in that table. So both of those combined are the compound primary key. Now, if I look at the other 2 fields, do I need to know the order number to be able to determine the product description? No, I just need the product ID. I do need both the order number and the product identifier to determine the quantity for that line item in the order. But that tells me I can split this off into a separate product table. All right. So that's what we're going to do to move ourselves into second normal form. Now, I still have some data problems. I've got 1135 and 1136 there. I've got my weird 4RR wine cooler there. I've got my wine cooler, wine spritzer. So I still have different descriptions for my products, but as I move to second normal form, I'm going to have to fix at least some of those. So now I create my new product table that says 444 is wine cooler. Whoop, actually it's supposed to be wine spritzer. So what do I do here? I can just type in wine spritzer, and product 444 is ready to go. Now, the other thing I need to do is I need to go up here. One of the rules that this diagram tells me is every product that shows up in the order details has to be in my product table. So let's look here. I've got that 4RR. That's not down here. So given the description, it's pretty obvious that's my 444. It's also a wine spritzer. So I'm cleaning up my data now. And actually, I'm just going to eliminate this field completely from my order detail table. So now I just have order number, product, and quantity. And now the 444 has been fixed, and I can go down here and see that is a wine spritzer. Okay, so now we're in second normal form. Let's move to third normal form. To get there, we're going to look for what we call transitive dependencies. So to get to second normal form, we look for partial dependencies. That's the technical term for looking for a field that depends on just part of the primary key. Now we're looking for what we call transitive dependencies. Are there any fields that don't rely on any of the primary key for us to figure out what they are? And for that, we've already simplified our order detail table and product table about as much as we can. So let's go back to the order table and see what's going on there. So we've got the order number, that is our primary key. What things in here can we figure out without relying on the order number? And if you look closely enough, you'll notice that last name, first name, state, and zip don't really depend on the order number, but on the customer number. So we're going to split off customer and make a separate table there. And based on how we were able to clean up products by doing that, you can see that that will force us to have some consistency for our new Captain America. All right. So let's do that. Oh, let's take a look at one other thing. Is there anything else that might not depend on the order number? This one may not be quite as obvious, but take a look at the tax rate. So that's a sales tax rate. And it could be by state. It might be by zip code. It looks like the sales tax rates by zip code are all the same for a particular zip code. So that's possible. Obviously, this is a simplified example. Tax tables can get quite complex. Let's just say it goes by state. So we're going to use the state sales tax rate and bring that off into a separate table. So now, moving over to third normal form, we have a new customer table where now we just have the one record for John Black. So we can change his name to America Captain, and he's ready to go. All right, so now you look at it, we've got 5 tables where we just had one before, but each table is very clean, very focused, and doesn't have redundancies in it. Whereas going back to the original, that was a messy looking table with all kinds of information kind of just scattered all over the place. So you can see now the normalized data allows us to answer these questions and make changes quite easily. So the downside is now we have 5 tables to join together. So if we want to pull that information back out, then when we create a query, which we'll get into when we start discussing SQL, we're going to have to join a lot of tables. So that process can be a burden on the database. But when it comes to recording new transactions, a normalized database in third normal form, like you see here, is the most efficient way to record new transaction activity for your company. So anyway, hope that gives you a feel for how database normalization works. Let's get back to the reading module.